Hey, hello YouTube. Welcome to my channel. Today, let's look at leetcode98, validate binary search tree. This is a very often asked question in code interview. I was asked once when I was interviewed with Google. Back to that time, the only thing I know about binary search tree is that if the binary search tree is doing the in-order traverse, we will have a sorted list as output. So my solution was to traverse the tree and form a list, and then check if the list is sorted or not. So back to that time, I thought I gave a good answer to this question, but apparently this is not the optimal solution for this problem. So let's jump to the content, look at the solution, how to solve this problem properly. Okay, now let's look at how to solve validate binary search tree in a proper way. So the key thing to understand is in binary search tree, each node has its range. So start from the root, we can define the root range is minus infinity to infinity because we don't have any limitation yet. So the value for the node can be anything. In our case, we have a 5 here, so that satisfies the range. So this is good. And then after that, we continue verify. So the children of the binary search tree inherited the parents' lower bound, and then it used the parents' value as the upper bound for all the left children. And then for the right children, it inherited the parents' upper bound, then using the parent value as its lower bound. So now we have a two range, and we need to validate if the node value satisfies this range. So in this case, yes, it satisfies here, and also the right nodes also satisfies. Then we keep on doing for all the nodes, traverse the whole tree, and after we finish this, if all the nodes satisfy their range criteria, then we have a valid binary search tree. If one of the nodes violates this constraint, then it's not valid. So this is the proper way to figure out if the tree is valid as a binary search tree or not. Okay, now we know how to do that. Let's look at the code. So we basically define this DFS, and in this DFS, we gave three parameters. One is the node we are checking, and then lower and upper are the range we are given. So when we start traverse the tree, we first give infinity, minus infinity, and infinity as the range. So this call is actually associated with this one. So here, and then after that, we will check. This line is to check the condition if the node value satisfy the range criteria. If not, we simply return. We don't have to continue anymore. But if that's valid, then we keep on doing this for the left children and the right children. So as you can see here, we inherited the lower bound from the parent, but we use the parent value as the upper bound for the left children. And same here, we inherited the upper bound from the parent, and then using the parent value as a lower bound. And then we combine them using this AND to make sure both the left and right tree are valid. Now, if this is true, then we know that okay, we have a valid binary search tree, and this recursive manner will guarantee that we traverse the whole tree and make sure all the nodes satisfy this condition. So that's the way to verify if a tree we're given is a binary search tree or not. Okay, thank you for watching. See you next time.